Hello everybody to the first virtual team gathering for Kuryr. This first session is going to be led by me, and it is about the controller high availability. And the reason why we're having this discussion is because right now the Kuryr controller, which is the component, as most of you know, that watches Kubernetes for events, ends up transforming that into resource acquisition and management against Neutron and possibly other entities like Octavia. Just assumes that it's the only one doing things, and it doesn't have any sort of high availability. So you would rely on when it falls to start it with a watchdog or something. Which, by the way, is probably when we split the CNI part into an executable and a daemon, probably that's the project's going to have. Since it's going to be locally run, you'll have something like systemd starting it if it would fall. All right, so since the goal is clearly set, which is to be able to have multiple instances running, and that when something goes wrong with the main one, the others do the job, or that it fails over, or that you have active in the future, and so on. Okay.
Today, one question.
Yeah, sorry. I was just checking the chat, so that Jaivish could not hear us. I wonder if he can hear us. No. Well, anyway, yeah, go ahead, please, Irena.
Why not start by active? You mentioned that it may be the approach for the future, but why should we start with active passive?
So that's a good question. The answer to that is so that we can have something in place for sure in this cycle, because I think that active would probably take us a bit longer, and I'm gonna go into the details of why I think that when I explain the options that I think that we have. Because the first option that we have, if you're following the Etherpad, it says Kubernetes Controller Manager Style Leader Election. It has some requirements, like since you're using Kubernetes facilities, it demands some things, like the controller then will be under a replication controller, and it will be running spots. And it will be, and what it does, it uses the endpoints to keep track of the leader by putting annotation, similarly to how we do for services. We also modify the endpoints in a similar way. Then it has some limitations, like I put here that if some computer's clock goes faster than the other, it may end up with having more than one leader. However, I don't really mind putting the requirement that all the nodes of your cluster must be NTP enabled. So I think that's not that bad. I don't think we need to be more fireproof than the scheduler of Kubernetes itself. Anyway, and then so if it uses endpoints, obviously it's heavily using the resource versioning, and there's two options then of how to use that. One option is we take the logic that currently lives in the Kubernetes repository in PKG client leader election, and we implement it as another worker of the Kubernetes controller, and then whether it is the leader or not would live as a property of the application, something that can be consulted by all the green threads. The other option is, since we're already enforcing that the Kuryr controller must be running as a pod, we can just have there is a container in the Google Container Registry called leader-election that it already does that, and it exposes it via HTTP. So you can just curl to localhost to see what's the name of the leader, and if it's not your own name, so you just know that you're not the leader, and you can inhibit yourself from modifying things. That's pretty much what this option is about. And obviously, if we would be using this container, this extra container as part of the pod, this means we don't need to code anything apart from just doing these gets. You will have to probably ending up doing a lot of gets, or you can cache that for like if you have a result from less than a second ago, probably it's safe to assume that you still don't need to make another get. But well, all those are optimizations, right? And another important point is, of course, you will be modifying the cluster, like the lease. You'll be renewing it in a configurable period. So by default, I don't know, something like 2 seconds is what they have in the controller manager. So that means every 2 seconds you're gonna have extra modified endpoints. So the handler that is watching the services and the endpoints will get extra events. So we should filter that, or just do like OVN Kubernetes does, which is that the endpoint events, they have them cached and they only bubble up for the handler if the IP is changed. We could probably do the same on the client. Again, optimizations. So that's the option of just using what is there. The other option is to roll our own HA. And for
Tony,
so
if you don't mind, so I think we are missing another option actually. Let's think about why do we need active-active or active-passive.
Right.
So what's the problem with only having one instance of controller, right? So right now the controller is like it starts really fast, right? So it's pretty much stateless. Well, right now it is, but we do expect to add some state to it. But well, let's get to it later. So my point is that as long as our startup time for the controller is rather minimal, like about a couple of seconds or so, we actually can just have active nothing.
You mean to have just failover?
Yeah, absolutely. So we just have, well, for example, replica
equals 1 and the replica controller.
Yeah, with just one replica.
Okay, let me put it. Kuryr controller as a pod with just.
It doesn't have to be a replication controller. It could as well be run by CoreSync or whatever else.
Yeah,
but
of course.
It's just the most simple way to use Kubernetes for our case.
Of course.
So my point is that comparing between active-passive and active-nothing, I'm not sure if we have any benefits from active-passive, like from running several instances of controller. But of course, if we have active-active, that's completely different story.
Right. So the idea that I had behind adding the leader election and to have multiple pods running at the same time would be so that we're one step closer to doing active-active, so that we have some way of checking that the progress is like happening on the right direction. But if we only wanted failover, yeah, you could just have a single replica, like we will do for the CNI split.
Yeah, but I mean, right now you can actually, I think you can actually run several instances of the controller. That's before we have resource management pool.
Yeah, but they will be contending.
Yeah, right now we have protection guaranteed by Kubernetes resource versions. We have some overhead of creating and removing those conflicting devices or entities, but it's it should work, right? So maybe we could think about optimizing those conflicts, and actually that's what I expected from the pool resource management implementation. So I think it probably relates to Lou's session, but
right. Well,
yeah.
but I mean, it's all part of the VTC, so we can keep popping up things from other sessions, as long as we don't go too much into them. One thing that I had in mind, like I didn't put it on the Etherpad because it's a bit of an extra, was that in active passive, you could have things like the passive nodes be taking care of cleanup or other side tasks, but like just to spread the load a bit.
Not that passive. It's a bit different role.
Well, it was to give the possibility of having roles, right?
Mm-hmm.
But as I said, it's not the first goal. That's something that could be done.
In that case, you'll get all those concurrency problems, because you'll have to manage resources that were cleaned up and returned to the pool or whatever. And I mean, do we really need to complicate things?
Obviously, we don't want to complicate things.
Yeah.
All right. So, we would propose, like as a first step, is to either have a single replica with the replication controller and check how long. I think we should measure that, how long it takes for it to stand up again and start processing stuff. And that would be an interesting test. We could have a functional test out of that, and then to compare how that would look like if we would have the side container that does lead election, and just see until the leader is changed and events are properly translated.
It should probably follow the same pattern as Kubernetes does for its system services, right? Like running the scheduler and different controllers.
The scheduler as the controller manager do it with code. That is the second ref. If you click on the second reference, you can see it. And basically what it does is it runs the package from the first reference, which is it just runs leader election with the endpoint annotations that I said before, and that's what they do. I suppose also that they do it to react faster, but without measuring how much that impacts us, we're a bit blind for the decision, like how much we take to start processing events again after we go down. The thing is, if it's not a very strong exit, like I think the replication control, until it stands it up again, it can take like, I don't remember the grace period what it is, but it's quite a few seconds. It's more than 10 for sure. So maybe they do it because of that. I don't know. I have not checked it yet. How long it takes, like to purposely make an exception in the code and see how long it would take to start the pod again.
Well, and in case of leader election, you still have some polling interval. So you don't know.
Yeah, it's configurable. Yeah.
No, I mean, you just don't know when the node goes down or the service goes down. You know it because you have some checks that.
Yeah, it's the least period.
Yeah. So
right.
Either we'll be doing lots of requests, or we'll be doing not that many, but with pretty high
failover time.
Yeah. So that's pretty much my point. So if we go for leader election, how much time we can cut off from this interval,
right,
as compared to active nothing.
Over mode, yeah. Okay, so let me put here because I forgot action items. Not that I'm gonna fill them already, but just in preparation. All right, so I think that these are the three options that there are. One thing that I wanted to put, but I didn't put it as an option because I think that we should do that anyway, which is to define a minimal API so that we can have it driver based, and to have a driver that just does failover, another than one that relies on the configuration of the site container, and another that will do active-active. And to do it with the Steve door and so on. So my first naive idea that I had for the point to do that was to have the first call would be like set up leader election, which obviously in the case that you're just doing failover with a replica equals 1, you would not do anything. And then you would have some other point that you could put on a green, that we would put on a green thread, that would be try to acquire lease, and another one that would be is leader. That would be the other point. And then for some, like obviously the driver of failover would do no op on all of them, and the one for is leader, when we're running a site container, we would just do the curl and check if we're leader, and we would just have to make sure that when we perform changing actions, so the difficulty here is when we perform patch requests, obviously if you are on active-active, you need some extra API points, right, to decide if you take this event or not. So I suppose that there should be an API of does this event belong to me, and so on. Another one for the patch request is should send, probably, and yeah, those are the ones off the top of my head that we could have of API if we make it like driver based.
Yeah, I think we had this in DevRev at some point.
Yeah, I don't think it's there anymore.
I think we abandoned that DevRev, but I think there was some note about hashing the events by their IDs.
Sure. So in the active driver, does this event belong to me API endpoint, for which I hope I find a better name, because does this event belong to me is ridiculous. That would be the implementation, to hash the endpoints and return on the cluster membership. Like, I think that's the base implementation for it. So if you don't mind, like, does everybody agree about having it driver based so we can evolve in the future the active?
I think there will be several drivers. So in case of this filter, that will be it will be certainly something in between the main handler, the main dispatcher, and the watcher. So,
yeah, but do you think we need multiple drivers for that? I think it could be just the HA driver, and that it's called from different handlers. Well, sorry, from the dispatcher or from handlers. I don't necessarily think that we need one like to split it into smaller ones in this case.
Well, but this filter actually only corresponds to the active configuration, because
the other ones would just always return the event just as it is. The other ones would just drop the event and return none, right? Or
so the active node will always. So it does make sense, I think. So we have one driver that has some hashing algorithm, and another two drivers. Well, actually, one driver with true or false flag that will always drop packets or always accept them, and this flag would be changed based on whether if it's a leader or a slave. Yeah, I think two drivers, it makes sense.
Okay.
And it's not a handler, it's something on a completely different layer.
And I think for active passive, we still need to justify its existence.
Yeah.
Sure. Let me put, I'll put it on a separate point in the Etherpad. So keep discussing while I write, because I cannot concentrate on both things at the same time.
One more question I have, given the addition for resource pools, we were adding a state, sort of state.
Right.
And how this will be addressed in case of active, because it's more like global state, not something that event specific.
So it all depends how we manage the pool. If we use third-party resources or not. If we use third-party resources,
we make it stateless, so it's yeah.
Exactly. But I don't have any measurements if that is feasible, if we wouldn't put too much load on. I mean, otherwise you could say, okay, I'm making active, and I'm splitting along the lines of the worker nodes. If you had a lot of worker nodes, that could make sense as well.
Sorry, can you elaborate a bit?
Sure. So what I meant is, like, if you decided that your active, instead of splitting by event hash, is splitting by to which worker node the stuff is scheduled, you could say, okay, so I take care of these worker nodes, so there's no contention on the port allocation. So that's one type of resource, dynamic resources, which of course means if you're considering Octavia Amphores, this doesn't apply and it doesn't work then. Dispatching filtering. We put the note about need to measure failover time. I think that is the clearest mandate that we have out of this discussion. Need to measure leader election time to process next event. That's the action items that I could gather from what we have so far. I would like to know if somebody wants to take some action item, or if we want to make some kind of work group for HA or something, so that people say, yeah, I'm interested, I would like to do these trials and so on.
Well, I think I certainly will participate in that, at least on reviews.
Okay, cool.
Yeah.
Yeah, same here. And also wanted to suggest that maybe based on the output of all sessions, we can make global list, the action items and.
Yeah, and then we will have to so after the VTG and we have all the Etherpad with all the action items, I propose that we set up a meeting for next week, for Monday probably, if possible, to prioritize them as a team. Like, of course, if anybody wants to take one that is not a priority and work on it, so knock yourself out. We're happy with all the contributions we get, unless they are slowing down other parts that are more that have higher priority. But yeah, I think it would be good to have them as a priority, and then make the blueprints out of it and so on. I don't mind doing that, like to convert the priority list into blueprints and whatnot.
Also, another question, a bit related and a bit unrelated, is for the CNI split. Once there is split and we have the daemon part,
right.
I guess we'll probably need to address its availability as well, right?
Yeah, so since there is not a session, I believe, that tackles exactly this, I propose to discuss it now, if the rest of the people don't mind.
We can actually, I think we can take a very simple approach with a file log, with log file and the CNI exec, spawning daemon whenever it's absent. We have file-based logs which are atomic.
Sure, the FCNTL.
There is no reason not to use them, and they provide pretty much all we need.
Well, personally, what I wanted to do is to just implement like maybe make it driver based, since there's some people that still hate on systemd. So
I mean, we would avoid using systemd or anything else. We'll just spawn the daemon using our own CNI exec. So we don't need.
Right. Yes. I understand now. Yeah. Okay, so
it's reliable.
Check. Okay. Yeah. My thought was to just implement the daemon for so in with systemd you can just import the Python library that just make sure to send a message like a liveness message to systemd, and then otherwise systemd like kills you and starts you again.
I think another option can be just
because the problem is if it just a sec, Irena, just before I lose this out from my head, because the problem is if the daemon just becomes non-responsive, the lock would be kept, and that's a problem. But if you have something that you have a worker that makes sure that your telling that you're alive, it's much more reliable than
well,
the other option.
there is a solution to that. Just shoot it in the head.
Right.
Yeah.
But why not give Kubernetes manage it? Just like daemon set or whatever, they have some sort of that you need exactly one copy on each worker node.
Yeah, it works too. I just like the spawning by the CNI exec because I think it's most simple one.
Does
least amount of moving parts.
Does the daemon set have any logic for non-responsive pods?
I think it's a bit orthogonal, but you can have probes for responsiveness on your pod.
Computer unplugged from the dock. Can you repeat what you said, Irene, please?
I think it's not exactly related to the daemon set, but there are some probes that can be installed on the pod, and there is responsiveness probe and health probe, whatever. So maybe you can explore this. So just make sure that it's alive.
Daemon CNI.
So there are actually two alternatives, main alternatives. Either we manage it like under the Kubernetes, or we take care of its life cycle by ourselves, right?
Right. Well, I would say 3 options came out, which are proposals. Which is
I'll probably explain my idea as well. So in more detail, right? So we have CNI exec, which is called whenever it is needed, right? And when it is called, we can have this log file. And for liveliness check, we can also use the same file, just update timestamp on it. So the daemon
will be updating.
The daemon will be updating its state on this file, and well, it can actually write something there.
If the exec part cannot lock on it, it means it should kill what's there and start a new one. Basically.
No, if it can't lock it, it will check the timestamp either as file timestamp or file contents. It doesn't really matter. Well, stat is probably cheaper than read, but anyway. So you have this health check as long as it is implemented correctly in the daemon itself. But it would be anyway it will be a problem whether we implement it this way or in daemon set. So we still need some way to check its liveness. And if the daemon doesn't respond, we can also have a second check that if the CNI exec does not receive the device in some extended period of time. So we have like a short-term check based on this timestamp. And we can also add another check that if we don't receive the device, we do something like we can simply kill the daemon as long as
what I put on the Etherpad is that we would read /run/CNI underscore daemon.pit kill and start it anew.
It's simple and it's been done in many different systems, so we're not reinventing something, and it's really simple. I mean,
it's the old and tested and tried way.
Yeah.
No arguing about that. That's what everybody's been doing since Unix started. and what I was doing in the past as well. Yeah. Okay. So yeah, it's about having these three options more defined to check if we need more than one or a single one is enough. Like I would like us to take the decision with a bit more information about what each would entail. I think Ilya's one is quite clear, at least for the people that have implemented services in the past. This is so I don't think we need more explanation on that. And if somebody needs it, please feel free to ping, and then if you get answers to your questions, like to document it and to put it as a proposal. Otherwise, I'll consider that it doesn't need one. And then we would need more information about using the systemd watchdog facilities. I volunteer to do that. So the idea is to have blueprints for the three and then just approve one or approve more than one, which will mean that we will have to implement something that is configurable. But it would be something that we have to decide with a proper vote. And then if somebody wants to volunteer to make the Kubernetes daemon set blueprint, I would be very glad for that as well.
I can explore this one a bit more.
Okay.
I'd say that the file-based lock and daemon set are pretty much pretty close to each other, so the implementation could be very similar.
Yeah, I guess it's mainly who is responsible to spawn a new one.
Yeah, so. But systemd would be completely different, I think.
Sure, no question about that. No question about that. You would just not need anything on the executable part, and then what you would make is that the daemon part is started on demand. Like when you send a request, you would make a listener, right? For the service, and on the first request, systemd would grab the data of the request, would spawn the service, and would start it, so you would not miss any request. It's just a different way of doing things. I'll put it on the blueprint, and then we can decide what we want, and if we want more than one.
We can have a driver for this.
We can, if necessary. If we don't see enough gain, maybe we can. There is one area in which we don't have to have drivers for. All right, so
I think it's pretty clear now that we have driver for everything.
Yeah. Octavia people do also, so I don't feel so bad that we have drivers for everything. So yeah, we're not the only ones. All right, I don't really have anything more for this session, so unless people have questions, we can close it and give a bit more resting time until the next one. If I missed some action point or if some questions arise, you can add them to the Etherpad or voice them now, and I'll try to add them.
Okay, so let's go for lunch and then resume it later.
Very well. All right. So see you in half an hour from now.
Yeah. Bye, guys.
Bye.
Bye, guys.